Hi guys, welcome to our channel of Sciences and Mathematics. Today we are going to do a topic in mathematics that is under geometry. Of course, this is going to pertain the aspect of translation or just a transformation. And the topic of transformation, we are going to look at four different aspects. That is rotation, reflection, translation, and then we're going to look at dilation. So for that case, we're going to look at different ways in which these, of course, changes take place, all right, the way they can be represented. And this is very important for us because this is going to give us a clue, because this specific topic of transformation is relevant in our day-to-day life, especially in the branch of course, arts, architecture, and computer graphics. So for that case, thank you and welcome. So as I've said, we're going to look at a topic in geometry. Of course, this is introduction to transformation. Now this term transformation, of course, is a derivative of the term to transform, which in simpler terms just means to change. So in this case, the term transformation, if we can try to give it a definition, so in a detailed form, or just in a simple way, so that we can be able to capture what we have said. So this actually refers to changes that are done to a geometrical shape down to a geometrical shape on a coordinate plane by or through rotation, reflection, translation, or dilation. So there's different ways in which we can just frame this sentence for the definition, but of course it captures the aspect or the fact that the transformation refers to changes that can be done on a geometrical shape through the four main types of transformation that I've just mentioned, which is rotation, reflection, translation, or dilation. So in that case, we're going to look at these four different aspects of transformation as a branch in geometry. So in that case, we can just go ahead, and given this definition, and just go ahead and try to look at these four different aspects of course, transformation, as we have said. So in this case, we have said that we have four types of transformation, and the first one is reflection. The second one is translation. The third one is rotation. And the fourth one is dilation. So in this case, we're going to look at each individual types of this translation or transformation, so that they can be able to give us a clue on what we are just discussing about. So in that case, we will just simply start with reflection. Let's use that space over there. So we just start with reflection, and we're going to just give it, of course, discuss in short what reflection is. So in that case, reflection means making an image appear. On our common or day-to-day lives, we have mirrors at our homes. So that when our images appear in our mirrors, then we say that the images have been reflected. Now, for instance, if I have an image here, or just a figure like this, and this is a mirror or a mirror line that is here, then that image on the other side will appear like this. So in that case, the changes that have occurred from this figure to form an image, of course using that mirror line, that change or the transformation that is happening is what we call reflection. So this reflection has happened around a mirror line. Now to find the reflection of a point, maybe let's say that this is point F, about a line, let's call this one line I. So to find the reflection about a point or a mirror, just give it just an initial I. Now to find a reflection of a point F about a line I, we just draw a line from the point, a line that is perpendicular to I, and continues the same line on the other side. Now in that case, when we want to find or to do a reflection, in this case, we have said that of this point of the image, let's say this point, then we just draw a line that is perpendicular to this line I, or the mirror line, all the way through to the other side, of course, of that image. So in this case, then we're going to see that the distance between this point of the image to the mirror line is the same distance between the mirror line and this point of the image. So that is why we are saying that to find the reflection of a point F about a mirror line that we have given I, we just draw a perpendicular line to the mirror line I, and then continue the same line using the same distance to the other side. Now suppose this distance was just 3 centimeters, then that one, the explanation there implies that the other side of the mirror from the other side of the, of course, where the image is from the mirror line will be 3 centimeters. And that, of course, line that we have, imagine a line that we have drawn there for reflection will be, of course, perpendicular to the mirror line. So in that case, that is how we represent the reflection of an object. And we find that if this object had a point like O at this particular point, then the same case will happen in that there's a point O that is going to be formed on the other side, but we indicate this one as O prime. So in that case, the point O to the mirror line is the same distance from the mirror line to O prime. So that is one of the characteristics of reflection, in that the length of the sides, for reflection, the length of the sides are preserved. So in this case, the length of this side to the mirror line, and from the mirror line to O prime, the distance is the same. So one of the characteristics of reflection as a transformation is that the length of the sides are preserved. And in any case, of course, this was a geometrical shape, or maybe like a triangle or another, or if maybe I had the orientation of this particular object like this, then on the other side it will just appear at the same angle. So in that case, the first characteristic is that the length of the sides are preserved, implying maybe this length from here will just be the same as length from here. This length from here will be the same as length from here for the image, for the object or the figure and the image respectively. And the measurement of the angles, as well as I've said that if this figure is inclined this particular angle, then at this particular point you will find that the same inclination will take place there. So in that case, for reflection, the length of the sides and the measures of the angles of the image and the objects are preserved. Now, what is changed in this kind of transformation is the orientation of the image, of course. As I have indicated there, suppose, of course, this figure is a letter F, but as you can see from there, if we just write the normal alphabetical letters, then that one will be just an opposite of the letter F. It will not give us the normal letter that we expect. So in that case, the orientation has been changed. And then you'll find that for reflection, you will find that if in this case I was to indicate this figure, of course, now let me just do another one. If in that case I was just to indicate the figure, this is the figure and this is the image. So if I want to indicate that this one has these points, which are A, B, and C, then I'll have A prime, B prime, and C prime. So suppose I have a small insect that is traveling from point A to point C, it will go in that direction. But if I have another insect that is traveling from point A to C, it will go in that direction. So in that case, for the first case, the traveling direction of that insect will be clockwise, while for the image, the traveling of the insect following the alphabetical order will go counterclockwise. So in that case, for reflection, you'll find that the orientation has just changed, and that one, of course, can just be demonstrated like that. So for reflection, of course, reflection can be done or be done on another line on the axis, or as we have defined transformation as the one that is happening on a coordinate plane. Suppose we have maybe a line or another line that is just like the first one we have drawn here. It's a coordinate plane. And then we have an object like this. Then if we reflect it inside this line, then we shall have its image. I don't know whether it's that one is a representation, just we shall have its image appear as such. That's a reflection in the y-axis. So this is a coordinate plane. So if it's a reflection in the y-axis, then we shall have its image appearing like that. Suppose this image is still reflected in the x-axis, then we shall have its mirror image appearing like that. So in that case, that's how reflection happens both in the y and x-axis. And suppose we have a line that is different from this. Let's use an example of a line that is. So if we say that y is equals x, then that one implies for every value of y, maybe it's 1, then x is 1. So if we try to do a plot for that, you'll find that the line for y is equals x will run through the origin at that particular point. Still, we can do a reflection in that particular line. Now in this case, if we are given a line that is x, y is equals minus x, then that one will be opposite of the line that we have drawn. We're just having that orientation. So that will be the line that is y is equals negative x. And suppose we had our point here P, then the reflection of that point just appear like this along that point. So in that case, we can see that rotation can, of course, reflection can be done along a line that is defined on a coordinate plane. And we're going to look at that one in details when we're going maybe to use a coordinate plane that has been, the measurements have been indicated, so that it's going to give us a deeper clue on that. So in that case, we're going to look at different, of course, we're not just going to follow the order that we have listed above. We can choose any. So in this case, we were dealing with reflection. Now we can just look at a second one, which is rotation. Now for rotation, we are going to see that these different kinds of we're going to see that these different types of transformations have different properties. Now for rotation, suppose we have of course our a coordinate plane like that. That is the x and y axis. And then we have our point. Maybe if it's a flag, we have a flag at that particular point. And then we reflect that flag along the y-axis. Then we shall have this first image as such. So if we try to look at this image, then we can say that this is image A and this is image A prime. So as we have listed the characteristics of reflection, still they are maintained there, that the orientation changes, of course the angles are the same, and then the other properties, and we have talked about the distance from the point on the image along the nillar line to the point on the figure, that the distance is the same. So that's one. When we do like that, we can call it the first rotation. And then still we can decide to rotate this image, this is A prime, inside the x-axis. So this rotation, reflection in the y-axis, and the second one will be reflection in the x-axis on that side. So the third image, we are going to call it A prime prime, and then we are going to see that we can, of course, I gave a number line. I gave a line that was cutting through the Cartesian coordinates, and then I named it y is equals negative x, the one that I drew, and then said that rotation can be done, reflection can be done at a normal point along a particular line that is within that, of course, Cartesian coordinates. So in that case, we can transform a figure, or a figure that is maybe, this is A, we can transform A to A prime prime in a single step through a rotation of 180 degrees, which of course is showing this, reflections that we have done. So those two specific reflections that we can do, still we can do a rotation about 180 degrees in order to achieve what we call, we can do a reflection along the y-axis and the x-axis to achieve image A prime prime. But if we were to do a rotation, remember this one was a reflection. Whatever I've done, the transformations I've done for the first case from A to A prime to A prime prime, is a reflection along the y and x-axis respectively. Now for that case, we can just do a single rotation, a one-step transformation, which is a single rotation of 180 degrees in order to attain this. So in this case, it refers to, remember the first reflection, we said we draw a perpendicular along that line, it's going to be 90 degrees to attain that point. And then we said that, or maybe I can just say, if we made a line, let's call this one point P to P prime. We just have 90 degrees along that line. And then moving from P prime to, this is the same point, P prime prime, I still have to do a reflection of 90 degrees. So in that case, transforming this point from P prime to P prime prime, which is moving along this line, of course it's not just exact because I've done it hand-driven, hand-drawn. So it's going to be 180 degrees, of course, one step of 180 degrees. We can also rotate around the point of intersection of the two lines, but in that case, this is a simpler way in which we can, of course, do a rotation about the axis that we have done. So in that case, for the sake of rotation, if we were to do this one at 190 degrees to attain P prime prime, there are specific characteristics, of course, that we're going to note for rotation as the ones we noted for reflection. Of course, for rotation, you'll find that the length of the sides are preserved. These are the lengths of the sides. Now suppose this is from point M to N. So M to N, this is M to N prime, M prime prime to N prime prime. This length of Mn will be equivalent to M prime N prime, will be equivalent to M prime prime N prime prime. So that is what it refers to. That is one of the characteristics for rotation. And then the angles of that one, of course, will be preserved. Suppose this one was a 90 degrees angle for this figure at this point, it will just be preserved as well. And then the orientation, of course, will as well be preserved for this case. We said for reflection, the orientation will be different, but for this case, the orientation will be preserved. Of course, we will just use that one. We will just use another figure to demonstrate for that, but that's one of the characteristics for a rotation transformation. So in that case, we shall go to another one, which is of course translation. Just doing this one in summary, but when we shall be using the graphs and figures, we'll just be demonstrating so that we're able to check on the length that we've talked about, the angles, and then the orientation. So in that case, we are going to the third one, which is translation. And in that case, now for translation in actual sense means this is moving every point. Okay, translation is moving every point of a figure or shape. This is moving every point of a figure or shape by the same distance. Moving every point of a shape by the same distance in a given direction. So this translation means moving every point of a shape by the same distance in a given direction. So we can just look at these three aspects here, saying every point of a shape by the same distance in a given direction. So this one in a nutshell defines the characteristics of a translation. And suppose we are just going to give a demonstration for that and try to see what that one refers to. So suppose I have a figure here. This is still along the Cartesian coordinates. And then I have a figure which is a triangle. So suppose I move that figure in the opposite direction, of course, that is it's at the right. I move it across this axis, of course, let's call this one xy. So I move it across this axis, and I'll have that other figure showing like that. So in this case, you will find that every point in this figure, let's just list the points. So this is the point for the figure, A, B, C. And for this one, which has been transformed, we shall have C prime, B prime, A prime. So in this case, we have said that a translation is a transformation that moves every point of a figure, shape, or a space by the same distance in a given direction. So in that case, the direction that we have moved is this one. And as we can see that this particular point, which is A, has been moved from that point to this one. And for P, we are going to coincide with other lines, of course, but I've used yellow to indicate that. So for this other line, we just use this. This is C to C prime. So we can just use the other demonstration. So for that case, we can see that the figure has been moved from right to left in this direction, and then every point has been moved from right to left, that is in the same direction. And we're going to see that now for this particular kind of transformation, the line segments are taken to the line segments of the same length. So suppose I have this one stroke line segment, so it refers to the line segment that is being taken to a line segment of the same length. So which means this one has been superposed, or it's just been embossed on this direction at this particular point. And this lower line, we just use two strokes, has been taken to this direction, which is of course the same orientation. And then this third 3 strokes has been taken here. So that is what it refers to. We talked about the concept of segment. So the line segments are taken to line segments of the same length, and angles are taken to angles of the same measure. So in that case, if this angle was theta, let's say angle P. Now that we have talked how we denote angles, this is angle theta, then it will be taken to angle theta prime at that particular point. So that is what it refers to. Angles are taken to angles of the same measure, and lines are taken to lines of the same measure. Suppose this line was parallel, then this one will be parallel as well, of course, which means the parallelism is preserved in this kind of a transformation that we are calling translation. So in that case, those are some of the characteristics that I've mentioned, of course, which happens in this kind of transformation that we call translation. So when we are going to give examples, of course, we are going to see the magnitude of those lines, whether the parallelism that we have talked about, the measure of angles, and then there's one of the properties that we have not talked about, that is the midpoint, for the case of reflection and others, but we shall of course talk about those ones when we are just doing some of the examples. So let's go to the last one, which is concerning dilation, which is a fourth kind of transformation, geometrical transformation that we had mentioned. So for the last one, which is dilation, now to demonstrate it using a figure just like the others. I just use still our F. And just put another F there. So in this case, if we try to look at the two figures, and we say that is figure that is changed from one to the other, you can see that if we move from, let's call this one A, and then A prime. If we move from A to A prime, we shrink that figure and it becomes smaller than, it appears smaller than A. But if we are moving the opposite direction from A prime to A, then that figure has been stretched. So that kind of transformation is what we call dilation, which means to reduce or enlarge an object. So dilation means to reduce or to enlarge an object. Now if we try to look at another similar example for that, of course we are going to see that dilation is an unrigid transformation, which means that the original and the image are not congruent. We talked about the aspect of congruency when we were talking about line segments. We said that when the line segments are equal in size, then they are congruent. And we said that congruency can stretch the aspect of angles, figures, shapes, etc. So which means shapes can possess some aspect of similarity, which we refer to as congruency. So in that case, for dilation as a transformation, this aspect of congruency does not occur when you try to compare the images and the original shape. We'll find that the images, of course, will possess the same shape, but different sizes. Like the one that we have demonstrated here for A prime is smaller than, it's appearing smaller than the F. The A prime is appearing smaller than the A. Now in this case, we are going to find that the midpoints of the sides of the figures and images are going to be the same. And in any case, if we had maybe lines on the figures which are parallel, they will of course maintain that aspect of parallelism. So let's try to look at maybe a more clear image for dilation, which is going to give us a last bit of discussion. So for this case, let's consider two triangles. So if we consider the two triangles and maybe name them A, B, C, and then we have A prime, C prime, and B prime. We find that when we try to join the points of course, of this particular image, we join A prime, C prime with C, and then B prime with B. If we try to do a recession of these points, we find that there will be a common point at which these lines will meet, of course, which will form the center, form what we call a center point, which we have been referring to as a point of origin. Of course, these ones refer to as a center point. So in dilation, you'll find that when we try to compare the objects like the F are drawn, the lines that are joining to the specific points just converge at a center point. So in that case, of course, they will also maintain the midpoints. Suppose this had a midpoint. This line A prime, B prime had a midpoint. The same A, B prime will maintain the same midpoints, of course. And I suppose this line was parallel, then it will just mean that the other line will be parallel. And if in that case it was maybe a right triangle that we are trying to transform through dilation, the angles will just be maintained. They will be the same even if the object has shrunk or just been stretched, the angles will just be the same. So in that case, we have just done these 4 aspects of transformation, and I hope when we are just going to learn individual characteristics, properties, and maybe trying to do some kind of analysis in each of the 4 topics, it's going to be easier for us because we have already tackled the characteristics and trying to give a figure or demonstration on how this one is happening or how it is done. So for that case, that is going to be easier for us since we have at least a clue on what these specific topics refer to. So in that case, that is it for today. We're going to stop there. And next, when we're going to deal on the same subject, of course, we're going to just do it using examples. And perhaps it will be just on expanding on the 4 kinds of main kinds of transformations. Of course, there might be some others like shears, which we have not discussed, but we're going to handle them as we come across them in our other topics. So for today, thank you, welcome. God bless you. Bye.